Please put your hands together for Peter Sobotka, the CEO and founder of Corinex, and Denver Rumney, senior consultant of E.ON DynamiX. They're joining us to dive into the future of the grid is DynamiX, resolving grid constraints and enabling flexibility in the electric grid. Please give it up.
Good morning in Bilbao to everyone. My favorite mountain reminds me a little bit of our problems with decarbonization. So today my topic will be to talk about how is Corinex tackling the problems and what is our contribution. So we are a Canadian company of about 65 people based in Vancouver, and our key customers are E.ON, Iberdrola, and Chess. We provided about $100 million US in services and products to these companies. We see great acceleration in legislation, regulatory aspects for digitalization of the grid, and we are also very proud that we became the members of the board of Prime Alliance, as technology standardized in ITU. We are contributing to European Union, to different aspects. We are also, member of G3. About the company size, so last year we were about $4 million company in revenue. I would say testimony to the problems which we are resolving for the customers. In 2023 we became $18.5 million in revenue. In 2022 we had a $2.5 million loss. In 2023 we made $4.7 million net profit. So what is the problem we are resolving? What is it? Grid flexibility. As we all know, there are more and more electric vehicles being connected to the grid, and there are tens of millions of them, coming. In addition to that, there is distributed energy resources, which we somehow need to connect to the grid as well. Grid flexibility is enabling to create the balance now, in the grid. Now you can talk about the balance on high voltage, on medium voltage, but we are the first company, according to my knowledge, which is creating that balance on the low voltage. And why it is important? Because the key part of the problem is happening on the low voltage. So how big is that problem? You as investors, you invested billions of dollars to the products, which are today cannot be connected to the grid. So they are sitting in many countries idle. The problem is so big that EVP of European Union, it is hampering his, Green Deal for Europe because these devices cannot be connected. This is interesting from the point of view what we are missing now. If we miss these grid problems, what else we are missing? I would like to point out what I believe is being missed. There are many technologies. We know there is wireless, there is 5G, LTE, there is fiber, but what we are missing is location. When you are choosing the house, what is important? Location. So broadband power line technology is directly connected to the grid. It is an additional layer on electric grid. Why it is important? Well, if you take 4 low carbon technologies, electric vehicle, storage, photovoltaic, then you will have 100 households. On power 4, you will have 100 million connections, which you will need to connect on low voltage part of the grid. 100 million connections during the saturated market. Now, with all those electric vehicles, maybe the market will be not completely saturated. Maybe there will be only millions of those connections. But how you are going to connect them if you need to send everything to the cloud and then to send back, and you need to have a reaction time of seconds. So I'm just giving this to audience to think about it. Those money which went to those low carbon technologies before, which are today stranded, maybe now have to consider how this problem will be one day resolved. Of course, technology is performing well in terms of the high data rate and edge computing. So it is having every broadband power line chip is having its edge computing capabilities. So we are the company which is focused to create the operating system for these products. Where our product sits? So our product is a low voltage part of the grid. This is the most simple solution. I will have E.ON consultant, Denver Rumney, to discuss more grid flexibility and more complex solution. When last year we were presenting, this solution was at that time existing. This solution used mainly in Germany, currently started to be commercialized in Spain. So I'm very proud we are in Basque region, so it is in Iberdrola, as many can mention. The reason for solution to exist is to collect voltage and to report the imbalances in the grid. These imbalances are realized by installation of photovoltaics and EV chargers, which are usually connected to one phase. And of course, it is creating the imbalance. And you can have Browning effect if you don't have enough voltage in the grid. In terms of the customers for this solution, I would be very grateful to the first utility or DSO in the world to move this direction, German E.ON, where we are in second phase of the rollout in 4 DSOs in Germany. But last but not least, there are also about 10 German utilities today representing about 11 million customers who are with us going in this venture together. There was recently issued RFP by one of these independent German utilities. So we see this grid visibility will be helpful solution for many German utilities, but also for other utilities like Spanish Iberdrola. I will ask Denver to talk more about the grid flexibility. Before he will get on the stage, I want to clearly differentiate 2 things. Smart metering and grid flexibility are not the same. We are not smart metering company, but we are grid flexibility company, and we can provide grid flexibility also to existing solution which we can retrofit. Grid flexibility, we leave our meeting here, will become one day part of every grid and every single household in the world.
Thank you, Peter. Good morning, Bilbao. Just a very short, interesting fact about Peter. Usually when I see him, it's either in Germany or in the UK, and he always tells me that E.ON are his favorite customer, but I've already heard him twice already here say that Iberdrola is, so that maybe means something. So, Peter's talked about the BPL architecture and the communication system that Corinex have developed. Now, I'm going to talk a little bit about a solution that we've developed with Corinex. So, like any good solution, it requires a real-world problem. And that real-world problem came to prominence actually 4 years ago now in Scotland. And it basically came to prominence because building regulations were changing, and those building regulation changes have real implications with new build developers and all sorts of people with their homes. But that's where it bit first. Technologies like photovoltaic arrays, electric vehicle chargers, and heat pumps are becoming more and more prominent, and even back then, they were causing a problem for new build developers in Scotland. So, myself and my colleagues had the task, or jumped on the task actually, of developing a solution towards that problem. And we've done that with Corinex. Very importantly, actually an Iberdrola DNO in the UK, Scottish Power Energy Networks, they were involved as well, because this had to connect to their, the new build development had to connect to their 11 kV line, and so had to not exceed the capacities that 11 kV line could offer within the constraint at that time, very importantly. So, respect the existing limitations of grid infrastructure. We had to create a solution which offered some form of flexibility to manage that constraint within the constraint capacity, and we were doing that at the substation using real-time data at the substation. And SPEN were very, very insistent that we needed to use something that's secure, responsive, and resilient. And given everything that they demanded on us at that point, our only solution was BPL. So, what have we done? We've now basically built a solution that we've called DynamiX, and it starts at the secondary substation. So here at the secondary substation, you can see there's an existing meter, and there's a dynamics concentrator provided by Corinex. That's the heart of our system, very important. It reads in real time by Modbus TCP, what the real-time data flows are at that secondary substation. That's the first point for us then to manage the constraint there. Then from there, it establishes a broadband power line network to each and every home within the development. And we have a device in the home. We call it the BPL meter. But just as Peter said, this is not smart metering. There's another meter in the home, which provides the smart meter in the UK. This is here to provide flexibility. That BPL meter, the Dynamics Control Module, relays any commands from the Dynamics concentrator if we are approaching a constraint level. So we're talking about maximum export limit with PV or maximum import limit with heat pumps and electric vehicle chargers. We connect directly by hardwire, so we have Ethernet cables, or there is an optional 1T module, and it connects to the relevant technologies. What that gives us is an architecture whereby if we're in a situation like with PV, and there's a very, very high yield in summer, but low collective self-consumption across the development, the Dynamics concentrator will recognize that state at the substation meter, and it will command any PV arrays that are in an export state to turn down generation. So we're managing the constraint. Exactly the same for heat pumps and EVs with an import limitation. So again, the Dynamics concentrator does its job. It issues commands, and the low carbon technologies are managed to ensure the capacity is not breached. And this works for the new build developer. They can build the homes. The DNO or the DSO is happy because they can allow those connections on their networks. And the homeowners are happy because they get a shiny new house with all the shiny new technologies. Now, what we're doing with this, and we didn't realize it at the time, I have to admit, we're actually developing a communication architecture which secures the integrity of the grid at low voltage onto 11 kV. But when we have that architecture in place, we have multiple homes, all of the homes within a secondary substation boundary, all connected, and they offer a form of flexibility. The beauty about that is we can offer that flexibility into different revenue pools. And in the UK, many of these are open to us already. The wholesale market is coming online. The balancing market has been a while. And DSO markets are looking increasingly interesting. And we'll come to that later on, the actual value there. But acting as this local flexibility aggregator is an interesting new role. When you actually have control of all of the homes or the low carbon technologies and distributed generation within a substation boundary, you're in a perfect situation to flex those assets to the betterment of the energy system, to the distribution network operator, and also to the occupants of those homes. So, as I said, we're accessing different markets, and this is really where we're going with this now. So the base constraint, we have a grid code in the UK called G100 that's been developed recently further, and that allows us to do and scale this solution. But with flexibility, the value is really, really there. So wholesale market, 16 billion annual. That's a lot of energy trades. Now, as we scale this solution, and we've got secondary substations all across the country, we're going to build up megawatts of flexible value. And we can flex that into the wholesale market, the balancing market, etc. I mentioned before the DNOs. And on the right-hand side, you can see just what's going on here where DNOs are tendering out for flexibility. They need this flexibility from high voltage down to medium voltage. And that's where they've traditionally been looking. But look at the tendering versus the contracted. Contracted is roughly 50% of what was tendered. Very, very simple. The DNOs cannot get enough flexibility out of higher voltage connections to basically fuel what they're trying to do. Low voltage has an incredible value there. So if we're acting as that local flexibility aggregator and we're flexing all of those low voltage assets, we can now enter this market and we can drive further value to the DNO and revenue flows back to consumers. And that's a good story for everybody. And that is the solution today. I hope you've enjoyed that. I really enjoyed some of what you were saying there, Peter. The BPL architecture, as I say, is what we've built this foundation on, and it gives us the infrastructure to do so much more. Thank you very much.